What are strings? Well, in the previous video we looked at characters. So a character lets you store a single letter. So we can store A, we can store B, we can store C, we can store D, we can store 9, maybe 8, and so on, right? But suppose we tried to store multiple characters attached to each other like this. Well, if we tried to do that, we run into a compiler error because we can only store one letter or one element inside of a single character. And so this makes our lives difficult because oftentimes whenever we work with data, we want to store maybe like names or something, and those are obviously composed of multiple characters. So we need some kind of structure that'll let us easily work with multiple characters at once. And that structure is called a string. So a string, let's call this one my string, can be initialized to have the value of multiple characters like so. So everything inside of these double quotes is what we're populating our string with. So our string is going to have a value of A, B, C, D, E, F. Note that we're using double quotes instead of single quotes like we're using for the character. So let's just print out our string, show that everything works fine. And so yeah, we just get A, B, C, D, E, F. So let's name this someone, Nancy Reagan. And we can print that out too, and we get Nancy Reagan. Okay, cool. So under the hood, basically, a string, like how does a string work? Well, a string is just a sequence of characters, right? A string is a sequence of cars. Okay, well, what is a sequence of cars? A sequence of cars can be represented via an array. Okay, so what is an array? Well, we're going to see what arrays are like in the next video, but in essence, what we're doing is we're creating a bunch of little blocks of memory. So we're creating a bunch of blocks of memory when we do this assignment operator right here. We're creating a bunch of little blocks of memory, and inside each of these blocks of memory, we're putting a character. We're putting a character, Nancy, and then so on and so forth, where the last letter is N here for Reagan. So each of these blocks of memory contains a character, and then the string just makes it easy to work with these blocks of memory without actually having to work with the arrays. Okay, so that's just a little bit of theory. You don't really need to worry about it, but it helps because sometimes we can initialize strings in various ways. Weird initialization. To create a string, we can also use the syntax here where we use the new operator. So this new operator, it relates to how we create objects, and it's a feature of object-oriented programming. And again, we're going to see exactly how this works in a couple of videos down the road, but it's a good introduction, so we'll go through it right now. And basically what this is doing the same thing that line 6 is doing. It's just creating a new string. We can pass in some values inside of this parameter, inside these parameters right here, basically, inside these parentheses. And they let us initialize our string to whatever we want. So we can print out weird initialization, and we'll get the same thing. Okay, fine. Let's suppose we wanted to compare to see if this method of initialization did the same thing as line 6. Are these two strings the same? Well, in order to do that, we use something called here, let me show you. Boolean are strings same is equal to my string dot equals weird initialization. This function or method, we call them in Java, what this does is it takes my string, so it takes Nancy Reagan, and then it calls this equals function on this string. And this equal function, it basically takes in another string and it compares the two strings together. If the two strings are equal, then it returns true, and we store that value inside of a boolean. So if our string's same, then we're just going to print out strings on the same. And I forgot an ending quote right here. And so good. We see that the strings are the same. Okay, so now let's just change this slightly by putting an S in there, and we need an else. System.out.println. So now the strings aren't the same, and that makes sense because, well, we just added an S there, and Nance, this Nancy Reagan isn't the same as that Nancy Reagan. Okay, fair enough. Okay, so now let me comment this out, and what if I did this? My string is equal to weird initialization. Well, normally whenever we're checking equality, we can, for example, suppose we have two ints. Int A is equal to 2, int B is equal to 3, and let's say that we wanted to see if A is equal to B. Well, if we wanted to check that, we just use this double equals 2 operator. Is 2 equal to 3? Well, we know from, we know intuitively that 2 isn't equal to 3, so we're never going to go inside here. But just for the sake of argument, we all agree that this operator, it compares the equality of two values. Now, looking at this right here, will this double equals tell us whether the two strings are the same? Well, let's try to find out. And let me actually. So these two strings are the same, yet it tells us that the strings aren't the same. So why is that? Why aren't we able to use this double equals to? And the reason is it's a little complicated, and we'll understand it more thoroughly when we get to objects. But in essence, what this double equals to thing does is it makes sure that whenever you have two blocks of memory, right? So we have one block of memory here, and then we have another block of memory here. It makes it and then each of these blocks of memory, we're accessing it via a variable. So the first block of memory, it contains Nancy Reagan, and we're accessing it with this myString variable, right? Now the second block of memory, it also contains Nancy. Oops, I forgot to put a space here. Nancy Reagan, and we're accessing it with this weird initialization variable. So what this equality check, in essence, what it does is it checks to see if this variable and this variable, if these two pointers, we call them, point to the same location in memory. So myString, it points to this block of memory, but weird initialization, it points to this other block of memory. Even though the two contents of the blocks are the same, the places where these variables point to, the places are different, and so this equality check fails. However, when we use the dot equals to function, what we're doing is we're actually checking the contents of the string. So we fetch the contents of myString, we get this Nancy Reagan, and then we fetch the contents of weird initialization, and then character by character we compare to see if the strings are actually the same. So, moral of the story, whenever you're comparing two strings, always use the dot equals to function. Okay, cool. Now, one more critical fact about strings. Strings, we call them immutable. So what does that mean? Well, immutable, just the definition of it means something that can't be changed. When something is immutable, you can't change it. So if I create a string, non-immutable string equals hello, once I've created the string, I can't change its contents. So what I can't do is I can't do something like non-immutable string dot. So there's a function actually in string called replace. And what it does is it finds instances of one character and it replaces them with instances of another character. Okay, so intuitively it seems as though if we call this replace function and we replace one of the L's, actually we should use replace all. If we replace the L's with O's, then our string should look like this. Our string should look like this. HOO. So this is what we would expect our string to look like. However, an immutable string, if we were to do this, if we were to try this, the string would still be hello. And that's because we can't modify the contents of our string after we've created it. We can kind of get around that though by reassigning where our string points to. And I'll explain why this works in just a second. So let's look at what this is doing. So what we're doing is we're reserving a block of memory, and then we're storing hello in that block of memory. Okay, fair enough. And then this is accessed via the non-immutable string variable name. Okay, so now what we're doing here in the second line is we're replacing all the L's with O's. Okay, so what does this actually do? Well, it takes our original block of memory. And it copies it into a new block of memory. So then new block of memory. So it copies into a new block of memory that has the exact same content, right? It has the same contents except we get rid of the two L's. So this is what the new block of memory has. Okay, so if we don't have this right here, if we don't have that reassignment, well, our original block of memory here is right here, and it just has hello, and then we're just printing that original block of memory. The stuff that got changed, our actual change block of memory, it's never used. It's returned by this function. It's returned by this replace all function, but we never actually use it. But if we reassign where original string points to, well, then we take this non-immutable string, and now we attach it to this second block of memory. So non-immutable string, it originally pointed to this guy, but now it points to this guy after we reassign it, and so we use the contents of this block of memory from now on. Okay, so another final moral of the story: whenever you're working with strings are always immutable. You cannot change their contents after you've created them. There are a wide variety of functions you can use on strings, such as substring, char add, dot length. There's a wide variety. In the next video, we're going to go into more depth on how about how some of these functions work and how we can use them in our programs. All right, see you guys then.